Hey everybody, I'm going to do a little talk on scientific notation and significant figures and kind of just using basic math stuff. In a normal year, we'd be talking about how to use a calculator, which is kind of impossible to show you on Zoom because everybody has different calculators, and entering numbers is a little tricky on a computer, and it's harder to do. So I'll be doing some of it in lab, I think, and you'll have to kind of practice on homework systems about entering numbers and actually using a calculator. I'll try to talk about some of the issues that people have entering calculators. So, okay. Couple quick things here. So one of the things that about this topic is, at the beginning of every science class, my kids are taking high school science, high school chemistry classes, and they do significant figures at the beginning, and they do all these rules about significant figures. And they're not as necessary as people think. It's a common thing that people cover at the beginning. And I realized one day, looking at real science papers, how little people need those rules. And often, if you look through textbooks, I can find examples of many textbooks that don't actually follow the correct rules for significant figures that they start off by telling you that are important. So I'll get into that in a second. But it relates to just what is scientific notation and why do we use it? And so scientific notation, not too surprising, is for science classes. Yeah. And it means that you'll see a number in the that the numbers always have the same format. It's something, something, something times 10 to the minus 2, whatever it happens to be. And then there's always a unit. Put centimeter down here, right? So the important features that you see in all writing are you have to have a unit, and you have to have times the number, and then you have number, decimal place, and then maybe or maybe not more numbers. Okay. You can never have an orphan number. It's really important. If you ever were to write any kind of science paper or do any kind of note taking, you need to have that unit in there. If I say, how tall are you? And I go 6.2. 6.2 what? Meters, feet, whatever. Now, obviously, if you say, how tall is somebody? You kind of know you're talking about feet. And if they say 1.8, they're probably talking about meters. But that's your assumption. So you need to have units all the time. People say the units all the time when you're talking, and you need to do it in print. So first off, always put units down. It's a pet peeve of science teachers if you don't. Next thing is that if you always use scientific notation, you don't have any concerns about significant figures. It's a easier, simpler way to do it. So what does this term mean? Just real quick, in case you haven't done this before you've done exponents at least a little bit, is pushing buttons on a calculator. So when you enter calculator buttons, often people will push this button. This is the correct entry, right, to enter this. Like, if you push the buttons 1.23 EE times 10 minus 2, that'll give you the correct entry. Sometimes this button is times 10x. It's different places on different calculator systems. What you don't want to do is people will enter the button set up like this. They'd say 1.23 times 10, and then maybe times e to the negative 2. They may not, and I've actually had people not realize they're doing it wrong because they're dividing one by the other, and they do it consistently so that 10 cancels out. In your calculator, it is most likely that if you have an exponent button, and it might be EE, it might be EXP, it might be times 10, that includes the times 10 in the calculator. So whichever calculator you've got, and I would always recommend buying the cheapest $12 scientific calculator you can, like a TI-81 or something. whatever you got, take a few seconds and figure out, test your button entering system. So, enter the number 1.23 times 10 to the minus 2 equals, and then if you push equals, you should get something that looks like that. You should also be able to take a number like 0.0123 and turn it into scientific notation on your calculator. And again, there's usually a function button or a feature menu. It's different on every calculator where you can enter that number and convert back and forth. Most calculators will allow you to lock your numbers into scientific notation, which I kind of recommend doing. It's just the easiest way to do it. Again, so really, before I do that, there's a totally fun. There's an optional video called Powers of 10, 1977. There's a newer version. Don't look at the newer version. The older version is actually better, although the graphics are worse. It's a really weird little video. It's like what, 5 minutes long, something like that, and it's got this kind of wonderfully old graphics and stuff. And it's a walk through the universe at powers of 10. It's real. Oh, can't do full screen on this. Anyway, it's wonderfully old school. And it starts with people having a picnic, and then it zooms out, and then it zooms in, and it's neat. Kind of shows you how big exponents can go. Anyway, check it out. It's pretty cool. Okay, so what you should be able to do on a calculator is, enter numbers in scientific notation. You should be able to multiply by scientific notation. You should be able to divide by scientific notation. And many people think they do it right. And there's a lot of people who just never get used to their calculator. They never really understand how it works. I will do my best in person or through Zoom, whatever, to help you out with that. But test it. Make sure you can do it correctly. There's some homework questions where they'll have you do calculations. Make sure you can do it right. Make sure you can use your tool correctly. Let me get to scientific, significant figures. The example I always use is if I say, hey, how much did your phone cost? Like, hey, I got a new iPhone. And you're like, I don't know, like $900. I'll just make that up. How accurate is that? It's not, right? I mean, if you say $900 for an iPhone, and like, let's say, I don't know what iPhones cost now. Let's say $832.56. You take out the receipt and you say, mine was $832.56. How much did your iPhone cost? Like $800. Like $830. I don't know, something like that. Right? Those are, you say it in English, there's a sense of certainty. How much did your house cost? Oh, that was $500,000. That was $532. Well, you didn't, probably on your lease, it's probably like 532, 156.23, 23 cents, something like that. So there's varying levels of accuracy that people use all the time when they're talking about numbers that we can hear in their voice and the way they talk. But on paper, that just doesn't come through. If I say, how do you write $800? It's easy to say, $832.56. How do you write $800? If I say my phone is $800, so I take out $800 in cash, I walk into a store, they're like, no, it's actually $832. You don't have enough. What? Oh, I thought it was $800. Well, you misunderstood. So how do we write that? So allegedly there's this system of significant figures where, that's one significant figure and these don't count and that kind of stuff. It can be really confusing. So if I write the number $800 like that, that means that it could be anywhere from, $751, which you rounded off, to $849. It's in that range. They just rounded off to 800. If you want to say, yeah, that thing cost exactly $800, and you write the price like that, it's supposed to be better. But you know, the reality is if you walked into a store and they said it's $800 and they were like, oh, we just rounding off, it's really 849, you'd be annoyed, right? So what do we do for that? Are there rules for it? Yes, there are. There's rules about leading zeros and trailing zeros and stuff like that. Here's an easier rule. Just use scientific notation. Then it's easy. So if I say, how much does that thing cost? And you wrote 8 times 10 to the $2, that's pretty accurate. It's like, I don't know, it's 8. It could be 8.2. We all understand it's not very accurate. If I say 8.0000 dollars times 10 to the $2, you know, that tells me that it's exactly $800 and no cents. It rounds off real nice. It's real easy to understand. It's real clean. It works really well. So just always use scientific notation, and you literally don't have to worry about these rules of significant figures. There's a lot of rules that people talk about. You have to identify significant figures. You have to go over and learn them all. It's not that hard. Just use scientific notation. People don't like scientific notation because they don't know how to enter it in the calculator. Once you learn how to enter it in the calculator, it just makes everything easy. So the only time I don't use significant figures is when the number is basically something you can count on your hands. Or maybe it's like, you know, less than 20, 30, 40, something like that. So I may often say, you have 26.0 milliliters. And you know what? That's me being lazy. I should write 2.60 times 10 to the first milliliters. Often, if it's just times 10 to the first, we leave it off. And we cheat and we write 26 milliliters. Okay. However, if you're going to write like, you should never write this as an answer. Just don't. Don't worry about leading zeros. It's ugly. It looks weird. Just learn to write 2.6 times 10 to the minus third milliliters. You know, it's so much nicer. Looks better. By the way, how did I convert that? Well, one way to convert it is to just enter it in your calculator, push the scientific notation button, and that works. There is a system which you can learn if you care about this kind of stuff, which is if you move the decimal place over by 3, the number goes up and down by 3 on the exponent. You can do it that way. I don't teach that. It's so much easier simply to say, enter it in your calculator as scientific notation all the time, and really you won't have any of these problems. You don't have to learn how to move decimal places over. You don't have to think about it. You don't have to learn significant figures. You just use scientific notation and everything is easy. Again, if the number is relatively small, like 26, you know, whatever, 222, it's fine. You can go ahead and not use scientific notation, but I would just say, when in doubt, use it. It makes your life easy. It works better. And honestly, it's a lot simpler. Anyway, that's it for scientific notation and significant figures. Keep on studying.